Okay, hello everyone. From this class, we are going to start to discuss about Laplace transforms. Okay, so before we have to start the Laplace transforms for different functions, here I am going to suggest to all of you that you just remember these two integrals. That is your integration of e to the power ax into sine bx dx will be this much. That is your e to the power ax by a square plus b square whole into a sine bx minus b cos bx. Integration of this one e to the power x into cos bx dx will be equal to e to the power ax by a square plus b square whole into a cos bx plus b sin bx. Okay, these two integrals you have to remember, because uh, whenever we are going to try to find out the Laplace transform of sin at cos at, at that time this integration will be come up. Okay, at that time we have to use directly this integration value and then we are going to put the limit. So I suggest that you have to remember these two integrals. Okay, so in this class particularly we are going to discuss this integral. We are going to derive this integral value will be this much. Okay, likewise you can derive this integral value will be this much. So in detail we are going to discuss how this integral value equal to this much in this class particularly, right? So let's start. See, these two integrations already you have been studied in your plus 2 level, but may you have been forgotten. So only for that you somewhere you can write in your note. Okay, so first integration we are going to be do in detail. E to the power ax into sine bx into dx. Okay, so let how we are going to solve it. Let I equal to e to the power ax into sine bx dx. Let I equal to this much. So here we are going to apply the eyelet for this integration: inverse, logarithmic, arithmetic, trigonometric and exponential. So here exponential is your last second function and trigonometry will be considered as the first function. So this is the trigonometry function. Sin bx will be considered as your first function and exponential will be considered as second function. Okay, so what we have to do, that implies I equal to, here this one is your first function, so it will be written as sin bx integration of e to the power ax dx minus whole integration of derivative of the first function, that is your d by dx of sin bx sin bx into integration of e to the power ax into dx whole integration will be is there, so dx. So that implies I will be equal to, here this will be sin bx integration of e to the power ax will be e to the power ax by a, right, minus integration of sin bx derivative is nothing but b into cos bx, right, into integration of a to the power e to the power ax, that will be e to the power ax by a into dx. That implies I will be equal to, this will be written as 1 by a into sine, this is sine, okay, sine bx into e to the power x minus here you can see b and a both are constant taken outside of the integration. We found cos bx into e to the power ax into dx, right? Again we have to apply the eyelet over this integration. Okay, so that implies I equal to 1 by a into sine bx into e to the power x is already there minus b by a, and here we have to again apply the eyelet for this integral. So as we know that this will be considered as the first function, so cos bx integration of e to the power x into dx minus, directly I am writing integration of derivative of this one cos bx is nothing but minus b sin bx, okay, into integration of e to the power x, that is your e to the power ax, e to the ax by a into dx, right? Okay, put it into the square bracket. So that implies I equal to already 1 by a into sin bx into e to the power ax is there, minus here b by a into cos bx, this will be e to the power ax by a minus plus, okay, minus plus, here b a is there, so taken outside b by a sin bx into e to the power ax into dx, okay. Okay, so that implies I will be equal to here 1 by a into sin bx into e to the power ax is there. Here you can see b by a will be multiplied with this one and this one, so minus b by a into cos bx into e to the power ax, sorry, here b by a will be multiplied means b by a square, okay, b by a square cos bx into e to the power x, then minus here b by a, here b by a is there, so b square by a square integration of sin bx into e to the power ax into dx, right? Initially we considered that this one e to the power ax sin bx dx is our I, so same thing we have to write I equal to, see, instead of this one we can write I, right? So this will be 1 by a sin bx into e to the power ax minus b by a square is there, cos bx into e to the power ax minus b square by a square into I, right, into I. So take this term to left hand side, so this, that implies I plus, this is minus is there, so it will be b square by a square, I will be equal to, here you can see 1 by a is there, you just write 1 by a into sin bx into e to the power ax minus here this term b by a square into cos bx into e to the power ax, okay. Okay, so that implies you just add it, take I common, so it will be 1 plus b square by a square, okay. So here I multiplied a on the numerator and divide one a, so it will be a by a square into sin bx into e to the power ax, and here it is b by a square is there, cos bx into e to the power ax, okay. Okay, so we found that that implies here you can see I into this will be a square plus b square by a square equal to, here you just write whatever written into e to the power ax minus b by a square cos bx into e to the power ax, okay. Okay, now here you can see that this a square will be cancelled out, okay. So what we are going to get, we can get that I into, that implies I into this one a square plus b square equal to, here a sin bx, a sin bx into e to the power ax minus b into cos bx into e to the power ax. So that implies I into a square plus b square, here e to the power ax is the common term with both these two terms, so e to the power ax taken outside, we get a sin bx minus b cos bx, okay. Okay, so that implies I will be equal to e to the power ax by a square plus b square whole into a sin bx minus b cos bx. Okay, so what we intend to prove, that e to the power ax sin bx dx will be e to the power ax by a square plus b square a sin bx into minus b cos bx, that we found here. Okay, that we found here, that this one, e to the power ax by a square plus b square a sin bx minus b cos bx. Because initially we have been considered that I equal to integration of e to the power ax sin bx dx. So here we found I equal to this much. Okay, so hence integration of this one, that means integration of this one, e to the power ax sin bx dx will be this much. Okay, this much we intend to prove, and here we found the same. Okay, so I suggest that if you want, you can practice also. This one will be this one, but for as per your BSc syllabus, I suggest that you practice it, but you remember these two integrals. You remember these two integrals, because whenever we are going to find out the Laplace transform of sine at, at that time that integral will be required. Okay, this integral here you can see e to the power ax into sine bx format is there. Likewise, whenever we are going to find out Laplace transform of cos at, at that time also we are going to require this integral. Okay, so thank you so much for watching this video. Thank you.